So these kinds of situations on page 126 are like real world situations. The numbers in them are real numbers that are real things. This is an actual medication. I believe this is the actual dosage of this actual medication according to when the book was published. And so, like, these are real situations in real things. Some of them are a little bit silly, but what we're doing here is this is about a good chunk of a pharmacist's job right here. This is what pharmacists do. They take these medication orders that doctors put in, and they double, triple check the doctor's math. Because if you give the wrong medication to especially a baby, it can be really, really detrimental. So we're doing double checking math for a doctor. And I just put my stylus down. Haha, put it in my pocket. Good for me. And so we're going to double check what this doctor said. The doctor orders 250 milligrams of this mildly impossible to say medication to be taken by a 19.8 pound infant every 8 hours. The label on the bottle says they should get somewhere between 75 and 150 milligrams per kilogram per day. So we're given some information in hours. They're telling us something about the day. So first thing we need to figure out is how many milligrams. This pen is too skinny. I need to fix this. There we go. How many milligrams per day the doctor has ordered. If they're taking 250 milligrams every 8 hours, how many milligrams is that in a day? If it's 250 milligrams per 8 hours, and we need to know milligrams per day, we need to switch this from hours to days. So I know there are 24 hours in a day, right? We know that. And we could deal with these numbers exactly as they are. Hours cancels out hours. We're going to get milligrams per day. We could absolutely just type it in the calculator and go from there. We could also notice that 24 does actually divide by 8, and we can simplify this a little bit. Because 24 and 8 will simplify down. They both divide by 8, and that gives us 3. So how many milligrams is this baby taking per day? If they're getting 3 doses of 250 milligrams. 750. So we have 750 milligrams per day. Great. We have another piece of information in here. We need to be in this window for milligrams per kilogram. So that's per kilogram of baby. So how many kilograms is this baby? I need to know kilograms of baby. How can I find the amount of kilograms per baby? Yeah, because I know the baby is 19.8 pounds. And I want to know kilograms. So I need the pounds to cancel out. So the instinct was right, but we got to be really careful. And that's why I always recommend setting it up as a fraction. Because I'm going to extend it down so that I can move it up. Just because I saw us doing the seeing stuff at the bottom dance. Oh, except now I can't see our units. Set it up as a fraction because your instinct was good, Celeste. Your instinct was really good. Only problem is I need to have kilograms, so kilograms goes on top. So we're going to take our 0.454 kilograms per pound. The word pounds cancels out. And what operation are we doing between these two numbers? Multiplication. So how many kilograms is this baby? It's not going to be 1.9. That's 9. 8.9. Yeah, 1 decimal place is fine. 8 times, I'm just doing double checking because it's not the one I have. Yeah. 8.9, and actually the way we'd round this would be 8.99 or to 9.0. Just on the way the numbers are, because it's 8.989. So 8.99 kilograms or 9 kilograms. Either way is fine. It shouldn't make that much of a difference, and if he's that close on his dosages, he's too close. Okay, so if I know the baby is 8.99 kilograms, and they've been issued 750 milligrams per day, how many milligrams per kilogram is it? Now we want milligrams per kilogram. So many grammage. How are we going to set it up? How many milligrams did we have in our dose? 750. And how many kilograms is the baby? 8.99. The way we figure out what this is simplified down is we type this in the calculator, which I don't know that I have it open right now. Let's see if it'll open for me on the right screen. Yay, it will. You have to wait for it to load. There we go. So we're going to do our 750 divided by 8.99. And it gives us 83.4. Let's take our 1 decimal place here. So this baby is getting 83.4 milligrams per kilogram. Is that in our window of okayness? Yeah. Because 83 is between 75 and 150. So these kinds of problems, this one is kind of obnoxiously grammy. Like there's a lot of grams in a lot of different units here. It's kind of obnoxious. But this is legitimately what some of the things that pharmacists do. So this is part of their job, is to do this math. And it's not just like counting pills and stuff and mixing them up. But this is how pharmacists keep us safe. That's why we ask pharmacists if there's any, medication interactions and if it's the right dosage and that kind of stuff. They double check all this math. Okay? Questions on this one? So kind of a little wild there in the middle, but. Okay. So we're going to look at the next one that's all about agriculture. And this is one of those ones that's a little bit of a stretch, but it's a little interesting when we get halfway down. So we own, as a collective, a 1-acre lot. We love it. We're starting a farm. Going to build our little commune. It's going to be fun times. An acre, or actually no, 640 acres is 1 square mile. And 1 mile is 5,280 feet. So what we're going to do, first things first, is I need to figure out the area of my 1-acre lot in something that's not acres. Like miles, inches. We're going to be dealing with inches down here, so getting it down into inches might be a good idea. So the way we're going to find out the area of our 1-acre lot is we're going to take our 1 acre, and we're going to convert it into inches, or into square inches. I know that 640 acres is equivalent to 1 mile. So if I set it up like this, it'll convert the acre to miles. And this is square miles. If we want to convert this into feet, I can do something over here using this guy. I know that 1 mile equals 5,280 feet. But I don't want just miles. I have square miles over here. If I need miles squared, if I square both of them, then we're into miles squared. 1 squared, miles squared. 5,280 squared, feet squared. Okay. Let's just deal with square feet because that's going to be, we're going to wind up with some really big numbers here. So the word acre cancels out, the miles squared cancels out, and we're going to do some multiplying here. We're going to take our 1 times 1 times 5,280 squared over 640. And that'll give us our feet squared. Everyone see where all those pieces come from? Because there's a whole lot of pieces there. Okay, so this is going to give us the square feet of our land. I'm going to need some more space, so I'm going to give us a little more room over here. So what we're going to do is we're going to type this into our calculator. 1 times 1 times 5,280 squared over 640. 1 times 1 times 5,280 squared over 640. And we're going to find out how many square feet we have. 43,560 square feet. Feet squared. So that's the area of our lot. That just gives us the space of my box, my land, table, whatever we're choosing. If I have my 1 acre lot, I don't have a board over here. Let's pretend that the back of my notebook is our 1 acre lot. And we get 1 inch of rain. And we're asked to find how many cubic inches of rain we have. We're going to take our area times our height. So we need them to be in the same unit. So we found our area in square feet. Now we're going to need square inches in order to find our inches cubed. So if I have feet squared and I want to go to inches squared, what do I know about feet and inches that I can use over here? If I want to get to inches squared. How many inches are in a foot? 12. But that's 12 inches in a regular foot. If I need feet squared and inches squared, I need to square it. So we can use the units that we know to help with the stuff that we're not sure, because, you know, coming up with how many square inches in a square foot, bleh. But I know 12 inches in a foot, and we can use that information to help us with it. So we're going to type it in our calculator. It's just the 43,560 times 12 squared. And if you did this in the calculator, you can just go times, and it'll pull up your previous answer, 12 squared. And it's going to be an obnoxiously big number. We have 6,272,640 square inches of land. If we take that times our 1 inch of rainfall, we get our, so we have 6,272,640 inches squared of land times our 1 inch of rainfall, and we get, this is actually the answer for that first line, 6,272,640 inches cubed of rain, because we're timesing it by another inch. And our units get a little crazy now. So I told you it was kicking up a notch. They get really significantly more complicated here. So that's a lot of cubic inches of rain. Now in part B, they're going to start taking this back into the realm of sane numbers, because right now it's super gross. We have our 6,272,640 cubic inches of rain, and we're asked to find how many cubic feet. So we're going to go back the other way to convert our inches into feet. Once again, I know there are 12 inches in 1 foot. But I don't need regular inches, I need cubic inches. So we are going to put that exponent of 3 on everybody. 1 cubic foot is 12 cubed inches. So we're going to take our 6 million obnoxious number and divide it by 12 cubed. So if we go into our calculator here, I can take my big number and divide it by 12 to the third. We get 3,630. So we had 3,630 cubic feet of rain fall on our farmland. Then we're starting to switch into different kinds of units. If 1 cubic foot of water weighs about 62 pounds, what is the weight of the water that fell on your land? What are we going to do with our cubic feet and our weight? What operation are we going to do? Between my 3,630, I have too many digits there, 3,630 cubic feet and my 62 pounds. What operation are we doing? So 62 pounds per 1 foot cubed. Can we see it now? We're going to multiply these together. The 3,630 feet and my 62 pounds, my feet cubed cancels out, and we're going to have times 62. 225,060 pounds. That is a lot of water. cubic feet doesn't mean a whole lot to us right now. But 225,000 pounds, that's a lot. Okay, our last one in this annoying water problem is that the weight of 1 gallon is 8.3 pounds. Using the numbers that we have, how many gallons fell on our lot? So if we have 225,060 pounds, and I know that 1 gallon is 8.3 pounds. That was aggressive over there. My pounds cancels out. And how many gallons would this be? Have you calculated? How many gallons is it going to be? I have 225,060. And you can even set this up as our fractions, times 1 over 8.3. You can do this in the calculator just like this, with our fractions, exactly the way it looks like on our paper, just without the words. And we get 27,115 gallons. 27,115.6 and a half. So while 3,630 cubic feet doesn't make a whole lot of, we don't know what that looks like. I know what a gallon of milk looks like. 27,000 gallons of milk full of water. Because we don't want milk. That would stink. Ugh. Milk rain. Gross. 27,000 gallons of water fell as 1 inch across our land. That's how much water that is. So 1 inch of rain is a lot of water. It's a lot of water. It doesn't feel like much when you're in it, but it's a lot of water. Okay, so these kinds of unit conversions show up in story problems a lot. They show up in these kinds of unit conversion things a lot. The next one is, I think, very interesting. However, the math in it is super gross because it's space stuff, which means everything's in scientific notation because it's space distances. So we get like 10 to the 12th and 10 to the 14th. I think it's interesting, but it's also one of those, I'm not going to pull your teeth, you'll make y'all participate in it. So I find it really interesting, but I'm also not going to make you do it. So I encourage you to look at this one, see if you can figure out how many miles does light travel in a year. What this is this is the measurement called a light year. Buzz Lightyear's name is in fact the unit of measurement. A light year is literally how far light travels in a year. So you can do this unit conversion. We have miles per second out to a light year, and we can figure out how far it goes. We can use that to then figure out how far away stuff is in miles. Okay? So we're going to work more with these kind of unit conversion things in our homework. This is actually the last homework of the semester. The last one. We are 4 weeks from the end of the semester anyway. We are a week and a half from the end of the chapter because we're going to have a week of notes when we come back from break and then a week of a project. And then we're reviewing for finals. That's it. So we'll have a week of notes, a week of project, a week of review for finals, and then we're taking them. So we're coming real close to the end here. So I'm going to give you guys the rest of this time today to work on this homework. It is more unit conversion. It is unit conversion practice. It is not as gross, as I recall, as the ones we just did together. They are less awful because the ones we just did were pretty gross. They were pretty gross. So we're going to start working with scale a little bit tomorrow, and then we'll review that when we get back from break. But that's what it's going to be. Alrighty? So, yeah. Do the thing. Work on the project. Not work on the project. Work on the homework. And I'll intro you guys to your project stuff when we get back.